Hello friends, welcome to our channel Knowledge Amplifier. So in our previous video, we discussed several concepts related to Kafka Producer, Kafka Consumer, Kafka Brokers, Kafka Schema Registry, Kafka Connect, etc. etc. If you want to know those detailed explanations, you can go through the link given in the description box. So today let us try to understand the error handling part in Kafka Producer, which you should consider very carefully when you are preparing a framework for a production environment. Okay? So due to many reasons, it might happen the producer is not able to publish the message in our Kafka broker. Then in that case, how the error can be handled, on that only let us try to understand with several examples in in-depth intuition. Okay. So first of all, whenever you are preparing a production level code, then you should enable retry in your Kafka producer. Okay. So if you recall this particular architecture, this we already discussed while covering the Kafka Producer Internals in detail. If you want to know the detailed explanations, you can check my previous videos. Just a quick recap. Here we are starting the producer, and whenever we are publishing message, then as the messages will be sent via network, so we need to convert that messages to bytes. So first key serialization and value serialization happens, and then based on the key in which partition of the topic the data will be written, that is calculated. That is basically partition calculation. And once partition is calculated, we batch certain amount of records. Based on batch size or linger ms, batching happens within an in-memory queue kind of data structure. One buffer is there where this batching happens. And once either batch size or linger ms condition is satisfied, then the batch, the Kafka will try to write in our Kafka cluster. Okay. So if you recall, here we are trying to send the data. First it will check whether the batch is duplicate batch or not. If it is not a duplicate batch, it will try to write the data in our leader. And if we are enabling replicas, then in other brokers also, where for the same topic replica partitions are available, there also it will try to write. Okay. Now if the writing operation is successful, it will go to success handler, and then here you can publish next set of messages, or you can stop or do some other activity. But if due to some reason in this particular layer the message publishing fails, then it will go to this particular path, and then if we are enabling retry, what will happen, that Kafka will automatically try to make another attempt to publish that batch which earlier failed, right? Until and unless timeout happens, it will try to do retry. So suppose you are configuring retry value as 5. So 5 times it will try to retry until and unless timeout happens. Okay. So that retry you can configure to avoid error. For example, suddenly our leader broker went down. Okay. Our whole Kafka cluster, maybe it is down. Then due to that reason, our batch, it was not able to publish. But when it is having retry within that small span of time, suppose the Kafka cluster again became up and if it is running perfectly fine, so in that next retry, the message will be written successfully. Okay. And whenever we are configuring retry, we also need to make sure that we are configuring this particular value max in-flight request per connection equal to 1. And the reason also I explained in my previous video. Just a quick recap. For example, we are trying to write our first batch, right? But it failed due to some reason. It is having a retry. And by that time, suppose our Kafka cluster again spinned up, and if it is in healthy state, it might happen that the second batch Kafka will be writing in our Kafka cluster before the first batch again reattempted to be written in the cluster, right? So if the second batch is written before the first batch is written in the Kafka topic, then within a particular partition, the messages will no longer be in proper order, right? But we need to make sure that always within a partition, the messages are available in proper order. Okay. So to avoid that particular improper ordering of messages, whenever we are enabling retry, we need to make sure that max in-flight request per connection is configured as 1. In that case, what will happen? If retry is going on, until and unless first batch is written, the second batch Kafka will not try to write in our cluster. As simple as that. And if timeout happens, it will go to the error handler. Maybe you can store somewhere and you can have attempt in later point of time. Then the second batch will be written. Okay, cool. So along with retry, this property also plays a very important role. And in the Kafka Python documentation, it is clearly written, you have to make sure max in-flight request per connection is configured as 1 when you are keeping retry value greater than 0, right? You can check the documentation link that what property we need to modify to enable retry. Okay, so this is one approach to handle error. If our error get resolved within the retry attempt, then well and good. Otherwise, we need to follow some other approach, right? So I will come to that. Before jumping into that approach, that if after retry also, if it is not able to publish the messages, then what will happen? Before going to that approach, we need to understand one very important concept, and that is mean in sync replicas. Okay, I will come to that, but before that, let's consider one situation where we are having replication factor 3 for a particular Kafka topic, and ACK is configured as all for our Kafka Producer client, right? So in that case, what it is meaning replication factor 3? That means that in 3 different brokers, the same data will be replicated. Like here, this picture is showing the same. Suppose we are having a topic T1. Okay, for this topic, we are having multiple partitions. Now, suppose we are having a partition P0, we should be having same partition P0 in 3 different brokers, because here we are configuring replication factor 3, right? So here you can see that in broker 102, the partition 0 is available. In broker 101, the partition 0 is available. In broker 103 also, the partition 0 is available. This partition is replica partition, this partition is replica partition, and this partition is leader partition. The concept of leader partition, replica partition already I discussed in my previous video, right? So what will happen, that if producer try to publish the messages, then either we can configure ACK equal to 0, that means it will not even wait for acknowledgement, it will just fire and forget whether the messages are written successfully in the leader broker or in the replica broker. Our producer will not at all think about that, and then we can configure ACK equal to 1. In that case, producer will only wait for the response that in the leader partition the data is written successfully. Producer will not worry about the fact that whether the same data is replicated in our follower partitions properly or not. Okay, but if we are keeping ACK equal to all, then in that case, suppose a producer send the data to the leader, first the data will be written in the leader partition, and then from that particular leader, the data will be sent to the follower brokers. In those partitions also the data will be written. They will send acknowledgement to the leader, and once the leader broker get all the acknowledgement from the replica instances, it will send the final response that the data is written successfully in the leader partition as well as the data is written successfully in the replica partitions. Okay, so that's what the importance of ACK equal to all. This is the safest option, but obviously you can understand it will take some time also, because it will wait to make sure that the data is copied in all the replicas properly. Okay, now suppose you are having this kind of configuration, replica factor 3 and ACK equal to all. So in that case, obviously it is expected that the same data will be replicated in 3 different brokers in the respective partitions properly. But suppose this particular broker goes down due to some reason. Okay, so now we are having only 2 active brokers. So when producer will try to publish the data in the leader broker, the data will be written successfully, and only in this follower broker the data will be written. Okay, so in 2 places the data is written, but the replication factor we configured as 3, right? So the condition will not be satisfied, because at least we want to make sure same data is available in 3 places, but that is not happening because one broker went down. So in that case, what will happen? The message, it will not able to publish here, and it will throw an exception that as of now the condition is not satisfied based on the configuration of replication factor and acknowledgement, right? So in that case, either you need to configure ACK equal to 1 just to make sure in the leader broker the data is written, or you need to decrease the replication factor, right? So whenever we are configuring these 2 properties, then another property comes into picture and plays a very important role, and that is mean in sync replicas. Okay, so like in this context earlier we have seen, if we are keeping replication factor 3 and ACK equal to all, then if any single broker goes down among 3 brokers where our partitions are available, then the producer will not able to publish the message. But suppose we are configuring mean in sync replica as 2 in the topic level, then what will happen, that ideally it will replicate the data in 3 brokers in 3 places where our partition 0 is available for the same topic. But suppose one broker is down, okay, then earlier the message itself we are not able to publish, but if you are keeping mean in sync replica as 2, then what will happen, the data will be coming and it will be written in leader broker successfully because it is up and running, and here this broker is also up and running perfectly, right? So here also data will be written. So at least there are two places where the same data is available just for backup. So here, if we are not having this broker, earlier message itself we are not able to publish, but if we are configuring min in-sync replica 2, then as in two places the data is written successfully, so it will consider that as success and it will send a response that the data is written successfully. Okay. So in simple words, if you are having replication factor 3 and ACK equal to all, then all three brokers should be up and running. But if you are having replication factor 3 and ACK equal to all and min in sync replica is 2, then if one broker goes down, then also it can work. Suppose another broker goes down, only one broker is active. Then in that case, only in one place the data can be written, right? So minimum I want in two places the data has to be written, but here only in one place the data is written, right? So in that case, it will not consider that as a successful write, and it will send an acknowledgement that as of now problem going on in the cluster, please take care of the brokers, etc., etc., right? So along with ACK all, minimum in sync replica also plays a very vital role. And I hope you understood. In this context, if you are having minimum in sync replica as 2, and suppose we are having 3 brokers where replicated data is available but 2 brokers are down, then in that case the data will not be written in our cluster, right? So these are several reasons for which our producer might not able to successfully publish the message in our Kafka cluster. And now let us try to understand if retry also not helping us, like in this case if the broker is down, both brokers are down for a long time, after 5 retry also if it is not happening, then obviously it will throw an error, right? So how we can replay the messages, that's what try to understand. Okay. So the architecture what we can follow in this context can be shown like this way. So here we are having our producer client application which using API, it is hitting Kafka Producer, and then Kafka Producer is trying to write the message in our original topic. And due to broker failure or something, if after certain retry also, if it is not able to publish messages in this original topic, what the Kafka Producer can do, the Kafka Producer can write the same message or event in a retry topic. Okay, and then we will be having a consumer code which will read the data from this retry topic and try to re-ingest the data in the same producer topic. Okay, and if suppose later point of time, if in this side all the brokers are running fine and all the issues are resolved, then the producer will able to write the message in this particular topic only. Okay, so just in this case we need to make sure that we are having the retry topic in some separate broker. Okay, our main topic will be spreaded across different brokers, retry topic should be in another broker, so that if in that set of broker where our main topic is available, if there's some issue going on, then retry topic also should not face the same issue. If it is in different broker, so obviously the probability of having issue in that broker also will be less. So that way our Kafka Producer can publish that message in that retry topic at least. From there we can create a Kafka Python consumer code which will publish the message in the producer only, and from that producer it will try to publish that in this particular Kafka original topic. Okay, so this is one approach. Now the problem is this particular retry topic is sitting within same Kafka cluster, right? Suppose our whole cluster is down, not individual brokers. Due to some reason, if the whole cluster is down, then our producer will not even able to publish the message in the retry topic also. So in that case, what we can do? In that case, we can follow this kind of architecture. Okay. So what we are doing here? We are having our client application which using API, pulling some data and trying to publish using Kafka Producer, right? And due to certain reason, if it is not able to publish the messages in our Kafka topic, then after certain retry also, if the problem is not getting resolved, the Kafka Producer will not write that messages anywhere within cluster, because it might happen the issue going on with the cluster itself, right? So it is not a safe approach to write the retriable messages somewhere in Kafka, but rather we will write those messages which the Kafka Producer failed to publish in cluster. It will write that in a database which is sitting outside our Kafka cluster. Okay, and then we will be having a scheduler code where we will be writing some Python code or Java code something. They will read those events or transactions or messages whatever Kafka failed to publish earlier. It will read from the database, then using our Kafka Producer it will try to publish that in our Kafka topic. Okay, so because in this case the database is sitting outside our Kafka cluster, so if issue going on across cluster, then also we can easily replay our messages. Okay, just we need to make sure using scheduler we are ingesting all the messages whatever stored in database. No messages should be missed. Okay, so this is another architecture which is widely used in industry. I hope you understood different approaches to handle error in our Kafka Producer. And this is one of the question asked by one of our friend Kranti Kumar, like he mentioned in one of my video that thank you for your videos. The question he asked, what to do in case of failure, like for example server down, when trying to send a message from producer. Does Kafka provide temporary storage for failed messages that can be retrieved later, or else should we manually catch errors and store them in DB, retry them later manually? So the second option is safer because it will be overall outside Kafka cluster. So if problem is going on across cluster, then also the second approach will not have any issue to replay the messages and ingest them properly. Okay, so I hope Kranti you got the answer. That's all what I wanted to discuss today in this video. If you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.